and I have a horizontal velocity. Well, they're linked with time, and so I have an equation, right? If I can solve this equation, then I can get the answer I want. Here's the problem. I don't yet know the time. I do know that value, yes, but I don't know the time, and I need to find it. So this is stuff in the x direction. I'm actually going to label that. I'm going to create a column of sort of work I'm doing, and it's all going to be x direction kind of business. And I'm going to create a second column that's going to be y direction business, y direction work. I have to keep them separate after all. Now the thing is this, okay, this y direction motion is accelerated motion. I have a few equations that I recall related to accelerated motion. So there is one equation that's kind of simple. Final velocity is equal to initial velocity plus acceleration times time. Another one is my displacement or distance is equal to initial velocity times time plus 1/2 at squared. And another one is final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. I usually would write it delta, right? Delta right there. Okay. So I've got these equations to pick from. What do I do? Okay. I know that I need a time. I need to find that guy. And so looking at this equation, there's no time in this equation. So it sort of rules that one out, right? Maybe it could be useful. Just sort of rules it out, though. At least initially. Let's see if I can get to finding time some other way. How about this guy? It looks really simple, right? Well, do I know my final velocity? It's going to fall vertically as it moves horizontally. So there's a final vertical velocity down here right before it hits. Right before it hits. And I do not know that final velocity. So I have an unknown there, and I have an unknown there at time. Two unknowns, I really can't use that equation either. It's not useful. Right? It's not useful for a different reason. I don't have enough information to use that one, believe it or not. So this middle one, okay, I have to look at this. This displacement, well, I'm going to rewrite this guy just slightly. It's going to fall the height of the cliff. So my displacement is the vertical distance, dy. My initial velocity, remember my initial velocity here in the y direction is 0. So that times any t is just going to be 0. That's kind of nice. My acceleration in the y direction is minus g, right? So this plus sign turns into a minus sign, and I have my 1/2, and instead of a, I write a g. There's my minus g, and I have t squared. So check this out. Is this useful? I know that value. It's 4 meters right here. That's 0, easy. 1/2, easy. G, I know that value. That's 9.8. Remember, I already have accounted for the minus sign. The negative 9.8, it's already showing up right here. I've got it covered. So that's good, I'm good. And t, well, t is the thing I need over here, so I'm good. I'm going to rearrange this equation and solve it for t. And once I find the value of time, I put it into this equation, and I get the answer I'm looking for. Okay, so how do I do this? So, something to think about here. Isolating t, it's going to be t equals, I have to multiply both sides by 2. It's 2 dy and divide by g. 2 dy divided by g. But this is t squared, so I have to take the square root of both sides. Okay, so there we go. That's how I'm going to find t. But there's an issue. For those of you who are paying attention, you saw this, right? This was minus this business. And so somewhere in here, I've got a minus sign, and that puts a minus sign under the radical. And for our purposes here in high school physics, and even some college physics, you don't want to see a negative in a radical. You don't want complex numbers. It turns out, though, my negative sign is going to get canceled out. Because check this out. This dy, that's 4 meters. It's going to be moving in the downward direction. That's actually a -4 that we're going to have there. So here's the deal. I can put another minus sign here in front of this. And then when I write a number in here, I'll just put a 4, and there's the negative sign. And here I'm going to put a 9.8, and there's a negative sign. And the negatives are going to cancel, and it does work. Okay? So remember, we're headed downward, which is in the negative y direction. This is really a -4 meters for displacement. So before I run out of space on this paper, I'm going to start here. Or I'll finish here is really what's going to happen. I have, remember, keep it separate. This is my y direction stuff. I'm going to solve for time. And so I have 2 times that 4 meters divided by the 9.8, and that's all under the radical. The time that I get is 0.90 seconds. Okay. Now that's not the answer I want. The question really asked how far from the cliff. So that's this guy. But I'm going to take this answer for time and substitute it into this equation and make it work. So I'm going to come back here to my x direction side, and I have this, right? So my x velocity was the 11 meters per second. And now I know my time, 0.90 seconds. And so this displacement, or how far from the cliff the ball lands, I just work that out, and I get 9.9 meters. And that is the answer. Okay, so I want to do a quick review with you guys. This video is kind of getting lengthy, I know. Appreciate your patience. But I want to check out a recap of what we did. We saw that the initial kick was horizontal only. There was no initial vertical velocity. We know that for projectile motion problems, there will be no horizontal acceleration, and the vertical acceleration is only due to gravity. Okay, so a couple things we know about this kind of problem. We were told how high the cliff was, and we wanted to know how far away from the cliff the ball will land. We set our sights on this goal, but realized we didn't have enough information in the beginning. But I can use some work that I can do in the y direction, the vertical motion, to find time, and we ended up doing that and finished that work. And that got substituted back into the horizontal motion part, and we got our answer, right? So review this stuff, and in addition to the review of this video, maybe watch it again if you have to. I also want to encourage you, get into the textbook and read this stuff. You can understand this, you can get this, and it is worthwhile. Thank you for watching. I will catch you next time.